So, hello guys, welcome back to today's video. So, today we are going to understand the furthermore topics in the statistic. As you have any doubt or any query related to any topic, then please drop the comment. I will answer it and solve try to solve it. So now today's lecture we are going to discuss about the data distribution. But first of all, let's revise what we have covered till now. So for that, okay. So we have covered um, what we have covered in the session one was the what is the statistic. As statistic is nothing but collecting, organizing, analyzing, and interpreting the data to make the better decision. So we are collecting and for what purpose? To make the better decision for the our data. Then why do we need statistic? What's the need of the statistics in the real world? Like that answer, but because it summarize our data through it we can take the decisions, make the decisions, and various places it's useful. Then the another was the types of statistic. We what are the which are the types of statistics? Descriptive and inspirational. In descriptive, what does it cover? Can anybody answer? What it will cover? So descriptive statistic describes the data using the graph or charts or like average, etc. And inspirational statistic makes the predictions or generalization about the population using the sample. After that we have discussed about the population and sample. In that, what's the population? The whole group we want to study is and population, and the sample is smaller part of the population used to represent the whole. Like we can take the example, a school, all student in a school is an population, and if we consider like the fifth class of the student from that school will be the sample. Okay. After that, the sampling techniques. So which are the sampling techniques? There are five major sampling techniques. First is the simple random sampling. Simple random sampling is nothing but just every individual has the equal chance of getting being selected. Okay. After that, stratified sampling. Stratified sampling is a non-overlapping strata. Like we can take the example. And dividing the groups but non-overlapping strata must be there. And we can take example as the gender, in which the female and male, like that. Okay. After that, systematic sampling is like having the fixed system, like nth part to be counted, then it's like that. If we are counting the person and conducting that survey for the every fifth person, then like we have set the system. So it's the systematic sampling. Convenience sampling is easiest to reach but not always reliable as such. Output is easier to come but not always reliable. After that, cluster sampling is just like that the things are yeah, is cluster sampling is like dividing the data into the small cluster, and after that we perform the sampling. Then we have discussed about the types of variable. There are two types of major variables. One is quantitative and another is qualitative. So what's the quantitative variables? Quantitative variables is nothing but the numerical value. Like we can say, take the example as the age, height, weight, like that things. And in that there are two types of quantitative variables, discrete random variables and continuous random variables. In the third part we can say as discrete random variables. Discrete random variables, we can take example like number of children in the family. There can't be like 2.5 children, there will be 2, 3, 4, like that. So it's the discrete. And the continuous variable we can say as example as the temperature scale, or we can say is the height or weight, like that thing. Okay, in which that will be the decimal values. Okay, after that the qualitative variable is nothing, just the categorical values, non numerical values. For example, blood group, we can say gender, color, like that. Okay, this was being covered in the session, but after that we covered the in the last in the session 2 was the various measurement scales. There are total four types of which are there without saying list down. Okay. Session 2 was on the various measurement scale. In that we have covered nominal, ordinal, interval, and ratio. So what's the nominal? Just names or categories, no other important, like gender. Okay. After that, ordinal is the ordered categories. Example we can say as the rank. After that, interval scale, number with the equal gaps but no true zero, like temperature. Temperature will be in minus or plus, but zero, no true zero is present. Then ratio scale, like interval scale, but has a true zero. Height, weight, okay, like that. Now, frequency distribution shows how often each value or range appears in the data. Like we have calculated for the age group of 10 to 20, then how many students are of that age, then need to count it, and the count will be the frequency. Okay, make larger data easier to understand. It's used. Then cumulative frequency tells us how many values are up to a certain are up to a certain point. Helps in building the curves and predict the percentile rates. So cumulative is nothing but adding up the previous frequency count. Okay. After that we have seen the data visualization. So what's the data visualization? Data visualization, first bar graph for comparing the categories. It's used for categorical data. Pie chart to shows the parts of the whole, like for representing the percentage. Histograms for the grouped numerical data. It's used for continuous data. It shows the continuous graph. Then line graph shows the trends over a time. Okay, now we have to mention about the our last session. So in that what we have covered, can anybody answer the question? What we have covered in the last lesson? Yes, mean median mode, central of measure of tendency. Okay, so let's now note it down. Measure of central tendency. Okay, and that what comes, mean Okay, so what's the mean? Mean equals to sum of numbers divided by total number of divided by total number. Okay, after that, median. What's the median? For odd number, we can say middle element. Okay, and for even number equals to average of middle element, which is equals to like nth plus n plus 1 divided by 2. Okay, and what's the mode? Most frequently appearing value. Okay, mean is nothing but add all values and divide by how many are there. Then the median is the middle value. Arrange the numbers and pick the middle one for the odd numbers. After that, mode, the most frequent appearing values. Okay, after that we have discussed outliers. Outliers. Okay, so what's the outliers? A number that is very high or low and doesn't doesn't fit with the rest of data. Okay, like example 1 3 5 7 8, and we take 100. So in this, the 100 is outlier. Okay, after that we have seen five number summary. Five number summary. That first one was minimum. It's nothing but smallest value. Okay, after that second way was the Q1. Means what? First quartile. Okay, which is 25%. Okay, then we have seen was the median. With what median we can say uh, with Q2, which is what 50%. Okay, after that fourth we have seen was Q3. What's its third quartile? Third quartile. Okay, what's that percentage? 75. After that, last one was maximum. which is largest value. Okay. After that, what we have discussed was the IQR. Okay. First, let's okay. First, IQR. What's the IQR? Interquartile range. Okay. So what's that formula? IQR equals to Q1 minus Q3. Sorry, I wrote it opposite. Sorry for that. What it tells us how spread out the middle values are. Okay. Mm, Now the formula for Q3 as such is equals to mm, I need to watch it. Wait for one. Lower fence and upper fence. Lower fence equals to Q1 minus 1.5 times IQR. Okay, and upper fence is Q3 minus 1.5 times IQR. Okay, now what? So this was our revision part till now. What we have covered. Yeah. Okay, if you have doubt any, then please tell so we can watch it. Okay, now we will do the start now the today's topic, that's the data distribution. How the data distributed, how to analyze it and all the things. Okay, so first of all, in data distribution we will see how data is spread around the mean. For example, in the about the in the below distribution, data is tightly clustered around the mean, and because of the two outliers, the mean is behind. Okay, like the in figure you can see that the major data is spread around the major major data is spread around this part, but due to these 2 points our mean is behind. Like our mean must be somewhere at here, but due to these 2 points our mean got shifted to here. Okay, our mean got shifted to somewhere here, so it gets the behind. Now in this section we will see how data distribution starts with the histogram, then it becomes a frequency polygon, and eventually turns into density curve that represents the distribution. Histogram to frequency polygon and density curve. Okay. Now we also going to see an important normal distribution which forms a bell-shaped curve. This figure is showing us the bell-shaped curve. Like wherever you find graph like this, then it's called a no bell-shaped curve. Okay. Now First, we will understand the where which was left in the previous lecture was the variance and the standard deviation, which is the measure of the dispersion. Before understanding this thing, first we have to understand the sample and the population in the statistic. Okay, like this we have discussed only in our previous lecture. Let's say this circle representing the population and the smaller circle is the, if we extract the some part of the population, then it's called sample. Okay, we have discussed this thing. When discussing the mean, variance, and standard deviation, it's important to clarify we were referring a population or sample, as the formula used for each is differ. For both population and sample, the formula will be different. So now let's understand the variance. Variance is nothing but variance is a statistical measure that quantifies the spread or the dispersion of the set of data points around their mean or the average, we can say. To find the variance, we going to the first find mean of our data. So this our data and we have find the mean. Okay, mean is nothing but sum of the all numbers divided by total number of numbers. Now mean, and now after finding the mean, we have to compute the difference for each point and mean and squaring them. Okay, we are subtracting each point from the mean and squaring them. We got what the result, 250. Now after finding the mean, we have to compute the difference. Now just to divide the computed difference by the by the number, by the numbers of points in the data. Okay, we need to divide how many, 5, so we have divided by 5, we get the answer. Now after dividing the mean, we have to compute the difference for the each point, for each point. So the 50 is the variance of this data. Now to find the standard deviation, we have to just square the root the variance. Standard deviation is nothing but square root of the variance. Okay. Now we will see the density curve. First, once let's cover it from here also. So measure of the range, one is the range, and the second one is the variance. Variance is nothing but identity how two distributions are different, like have same mean. Variance tells us the how much the data differs, and the formula where mu is the mean, we have squared up, you know, only each data values and the number of the values we have squared up to, so squared the difference so the negative don't cancel out the positive. Okay, after that, standard deviation for mean how far element can be. Okay, the standard deviation is just the square root of the variance. Okay, like here we have taken the example. You can note the data and afterwards calculate it. Okay, now let's density curve. To understand a density curve, should first know about the histogram, which we have discussed previously. Now let's create a histogram and then understand. Okay, so this is the basic representing total data distribution of the age in a specific range from 10 to 100. Okay, now we just have to plot the points over the bars and connect them kind of making the line like we have done in the previous lecture. Okay, after that after this, now we just have to remove the bars and we will get the frequency polygon. The fewer beams we use, the more inaccurate our polygon be. Okay, now imagine you are using the more and more beams, the dot will be very closer, and eventually it will become a density curve. Okay, like this. Now this density curve tells us many things like our total area, and the area inside the density curve is 100%. We want to know how much percentage of our data is about the 80 age. We can easily get it out from the density curve. Like we need to just calculate this part. Okay, this density curve is telling us and one of the distribution is the symmetrical. It looks like this the symmetrical, like both the part from the middle line, both the parts are equal. You can see that. So it's the symmetrical distribution. The distribution is also called as normal, and it always follows a bell-shaped curve, and we talk about it a lot in the following parts. Like, so it's the normal distribution. This is the bell-shaped curve. Okay, after that there is no another distribution than that is skewed distribution. Basically there are left skewed and right skewed. There are two types of skewed distribution, left and right. The tail at the left, so left skewed, as there is the tail, you can see this the called tail is towards the left, so it's left skewed distribution, and the tail is at the right, so it's a right skewed distribution. Like you can see in the distribution, it's going towards the right. Okay, density curve we can now always in the skewed distribution, mean will be closer to the tail. As such, you can see this is the mode, median, and mean. In the right, in the skewed distribution, mean will be closer. Okay, mean is at end, and it will be closer to the tail in this also. The mode will be there where the most of the data exists, and the median will be at the center as usual. Usually the skewed distribution occurs when an outer when there is an outlier in the data. Examples we have here seen mainly because the tail part will be when to reach. When there are some outliers, then only the tail becomes. Okay, if we plot the points, it will look like this. So here's the major part of the data and two are the outliers. As you can see that right skewed, and if you have a skewed distribution, it's better to find the median than mid for the central tendency. And if we talk about the measure spread, it's better to check the IQR instead of the standard deviation. Like we have plot the graph, and you can see that there's the tail part because of the outliers. Vice versa works. If you have a symmetric distribution, it's better to use mean and standard deviation for finding the measure of the spread and measure of the central tendency. Okay, now let's see from here also. distribution. In this we have discussed bell-shaped curve, and most of the values are around the mean symmetrically. Okay. After that, empirical rule. This rule explains how the data spread in the normal distribution. 68, 95, 99.7, and rule. Okay, so this rule explains how data is spread in the normal distribution. 68% of data is within the one standard deviation. 97 is within the two standard deviation, and 99.7 is from three standard deviation. So in this graph you can see here. Now let's wait. I will explain you. Here there was one graph. Okay, so here I will explain you. Okay, so this is our median. Okay, this is our median. So and the distance so the these are our data points from this. This is our first standard deviation. It's our first standard deviation first. Okay, after that this is our second standard deviation is not standard deviation is nothing but the how far the our mean is. Okay, in this the mean, median, mode all will be at this line only because it's symmetric. So it gives us the idea of how far mean our mean is from the data points. Okay, so this like here it will be the minus mu and plus mu, and this is our the first standard deviation. This is our second, like that this will be our third standard deviation, you can say. So first standard deviation, at that part our 68% of data lies, as in these two this part our 68% of data lies, because that's why our median is at this point. Okay, after that in overall these areas our 95% of data will be covered up. Okay, 95% of our data will be covered up, and in last this tails part our 99.5% major part will be covered up. Agreed or not? Okay, so this is being here listed, and in this also it's like I have listed the same thing, that how to correlate with the standard deviation, but in this it's not properly visible to you. Like example, we can take the exam score. Most of the students are near the average. Okay, in this I have taken the one example. You can calculate. You can take screenshot and calculate afterwards. Okay, and now the Z score is coming up, but we will discuss in the next lecture as such. Z score will be discussed in the next lecture. So if you want, if you have any doubt or any queries, then please drop the comment. I will help you out. And that's for today's video. And please help me to drop to uh, get your doubts clear, to get your doubts like if you want any videos on another subject, then drop the comment. I will make sure that I create video on that part also. So that's for today's video, and keep practicing, guys. It's like first you won't like the things as such, but it's much important for the data science. It's very much useful. So your basic must be cleared of the statistics, and we are covering up the basic part, so that you don't face any difficulties in the furthermore part. So that's for today's video, and keep believing in yourself. Thank you. We will meet in the next lecture.